Hello everyone, welcome to this video. In this video, we shall be looking at a question from group theory. So here they are saying bottle caps that are pried off typically have 22 ridges around the rim. We need to find the symmetry group of such a cap, right? So what are the bottle caps that we use over certain bottles? These are the kind of caps, right? So here you can see these marks on the cap, right? So there in general there are 22 such marks which are present on a typical bottle caps, right? So I have labeled all these marks by the numbers 1 to 22. So here you need they are asking you what is the symmetry group of such a cap. Now you can very easily resemble this cap with a polygon having 22 sides, right? So you could have a 22 gun, whatever the name of this one is, right, with 22 sides. So now it is an even a polygon with even number of sides, so you can very easily tell its symmetry group. There would be 22 reflection symmetries that would be available for this particular group. How? So 11 would be the ones which are which would be passing through these darker edges, right? So it will cross all the the opposite darker edge. So there are such 11 lines. What about other lines? Other lines would be present which are lying in between these two lines, which are not passing through the darker portions, correct? So we would have something like this, right? So you can very clearly see we have 11 such lines which are passing through the darker edges, right? And we have 11 such symmetries which are in between those ridges, so that are mentioned by this 11. So there are such 11 orange lines and 11 purple lines, correct? So in total we have 22 rotation symmetries available to us. So 22 reflection symmetries and 22 rotation symmetries. Now what would be the angle of this rotation? It would be available when you divide the complete angle, which is this 360 degree by 22. So you would have the number of angle, right? So this the symmetry group of such a cap is a dihedral group, right? Where D22, where we would have the order of this group as 44, containing 22 as the rotation symmetries and 22 as the reflection symmetries. We do not need to classify the individual symmetries because we have justified this thing using the visual representation, right? So we have the dihedral group D22 representing the symmetry group of such a cap. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.